Hello everyone, this is Sangeetha, Assistant Professor, EC Department, SNS College of Engineering. So in this video I am going to explain about computer organization and architecture. So in this video we are going to discuss about what is computer architecture, what is computer organization, what are the differences between these architecture and organization, how does the CPU works, and how the data are how the instructions are executed, how the data are transferred between the different components of a computer. So first we'll move on to what is a computer architecture. So computer architecture refers to the design and structure of a computer system. So at high level, so this is called high level architecture, that is focusing on the way various hardware components are interconnected and how they interact to perform the tasks. So next, what is a computer organization? So coming to computer organization, it is a low level design. It is a low level, whereas computer architecture is a high level design and it is a low level design. So organization refers to the way the various hardware components of a computer system are arranged and interact to perform a specific task. So it focuses on the it focuses on the internal details of the hardware components and their interactions, including memory organization, instruction set architecture. So that is ISA, data path, control unit. So memory organization, how the memory is organized, accessed and managed within the system. So instruction set architecture means, that is ISA, the set of instruction that a computer system can execute, including the format of those instructions and the operations they perform. So various formats are used, various that is 8-bit 32-bit formats are used. So the data path, next the data path, the data takes through the various functional units of the CPU, including ALU and registers. And the control unit, it is responsible for coordinating the execution of instructions, fetching from the memory and controlling the data flow within the CPU. And next we will move on to how the computer works. So there are some units, there are some fundamental units, that is input unit, processing, that is CPU, and in CPU memory is available, and arithmetic and logic unit. So these are the main components of the CPU, and output unit. So the input unit provides the data and instruction to the computer through input devices like keyboards, mouse and touch screens. So processing, the central processing unit is the brain of the computer. So it executes the instructions stored from the memory. So the CPU consists of arithmetic logic unit, and it performs various arithmetic operations such as addition, subtraction, multiplication, and logical operations such as AND, OR, XOR. So these are the various operations done by the ALU. And a control unit, that is CU, that coordinates, that controls all the operations, that manages all the execution of the instruction. Next, memory. So memory is used to store the data and instructions that the CPU needs to access quickly. So the memory hierarchy includes registers. So register is the fastest but smallest storage. Cache memory, small but faster than the main memory, and the main memory larger but it is slower than the cache memory. So another memories are, that is secondary storage. So registers, cache memory and main memory are primary memory devices, and the secondary memory devices are hard disks, solid state drives. These are called secondary memory devices, and it provides larger larger area but slower storage capacity, and the storage that needs to be preserved even when the computer is turned off, that is it is a non-volatile storage device. Generally the memories are classified into two types, that is volatile and non-volatile memory. So volatile means if the system is switched off, all the data available in the system will be erased. And non-volatile memory, the data will be retained even if the power is switched off. And the next one is processing cycle. So the processing cycle, that there are fetch, decode and execute. That is fetch, the CPU fetches the instruction from the memory. Decode, that is the fetched instruction is decoded to determine what operation need to be performed. And execute, that is it performs the task indicated by the instruction. So write back, it is necessary the results of the operation are stored back to memory. And the binary representation, computer use binary code, that is binary means zeros and ones, to represent data and instructions. The binary representation is the foundation of all the digital computing. And the logical gates and circuits, computers process information using logical gates, which are electronic circuits that manipulate binary data based on the Boolean logic. So some of the logical gates are and or not. And software and operating system, it provides the instruction that tells the hardware what to do. That is, it is used to interact with the software, and operating systems are used to interact with the hardware. And the output device, the monitor and printers are the output devices. And clock speed, the main one is the clock speed. The clock speed of a computer determines how many instructions can execute per second, that is how many instructions executed per second. So higher clock speeds generally lead to faster processing, but other factors like number of cores, cache size and architecture also impact the performance. And the next one is parallel processing. Modern computers have multiple CPU, so that can work in parallel. It is called parallel processing. And next we will move on, how does CPU execute an instructions. So there are already we seen that there are some processing cycles: fetch, decode and execute. So the central processing unit executes the instruction in a computer through a series of the steps. That is fetch phase. The CPU fetches the instruction from memory. So the memory address of the instruction to be fetched is usually stored in a special register called a program counter. So the PC, that is program counter, points to the memory address of the next instruction to be fetched. After fetching the instruction, the PC is incremented to point to the next instruction in memory. And the next phase is decode phase. The fetched instruction is decoded to determine what are the operations need to be performed and what operands, that is data, are involved. And execute phase, the decoded instruction is executed by performing the specified operation on the designated operands. And the memory access, that is optional. Some instructions may involve accessing memory to read or write the data. In such cases, the CPU performs memory operations which include reading data or writing data to memory. And the last one is write back phase. For instruction that produce a result, the result is written back to the appropriate registers or memory locations. And next we will move on to how the data is transferred between different parts of a computer. So the data is transferred between different parts of computer using various communication pathways and protocols. The transfer of data within a computer involves moving information between different hardware components such as CPU, memory and storage devices, input and output devices, and various buses or channels that facilitate communication. So data is transferred between different levels of memory hierarchy, including registers, cache memory, main memory and storage devices. So the CPU interacts with these different levels of memory to access and manipulate the data. And there are some pathways, that is the buses. Buses is a collection of the group of wires that is used to transfer the data between one place to another place. First one is data bus, address bus and control signals. That is control bus. The data bus is a communication pathway that connects CPU, memory and other devices. And the address bus is another pathway that carries memory addresses from the CPU to another that is CPU to memory and IO devices. It is used to specify the location from or to which the data is need to be transferred. And control signals, along the data and addresses, control signals are used to coordinate the data transfers and operations. So these are the basic things of computer architecture and organization. So far we discussed about what is organization, what is architecture, and what are the important blocks of a computer, and how the CPU works, what are the how the data is transferred, what are the buses are required to transfer the data. And there is an assessment. First question is a difference between computer architecture and organization, and list the three types of buses. So already seen, buses or the pathway to transfer the data. And what are the different types of memory? So primary and secondary memory. So you have to list out what are the different types of memory under this category. Define ISA and define data path. Thank you.